Hey, and welcome back to the Turd Ferg channel. Today I've got an assistant with me.
Hey.
My assistant sounds so excited today. All right, so what is friction? I'm just going to give you a little quick definition here. Friction is it's a force. Oh wow, jam that in there. A force that opposes motion. So if you're trying to drag something, if you're trying to move something, it's a force that opposes motion. So anytime you're trying to drag something, let's say here's an object. Let's draw a better object than that. We'll draw a box. If you're trying to drag that box this way, I'm going to draw a big F to represent you trying to drag that force. Friction is going to be what holds back against you. So that's what friction is at this point. So when we think about friction, we think about a rough surface, something like this. So here's a nice rough surface that we've got going on here. So we're going to try and drag this thing across this rough surface. Well, let's go ahead and take a look at a formula for friction. Hey, brand new member of the physics team since 10th grade, Spence Florzak in the house. Say hello, Spence. Hello. Yeah, it's like a physics party going on in here today. So let's give you an equation. So the equation for friction is F equals mu n. Now, this is the equation for a frictional force. So let's kind of break this down a little bit so you understand it. This little f, and notice how I'm writing a little f, is a frictional force. Now, I want you to take note of something. Since this is a force, what does that mean the unit's going to be? Well, what? I just heard Spence say it. It's a Newton. There you go. Now, we got this funny looking letter right here, this upside down looking H. And if you're trying to interpret that, let's go to elementary school here. There's what your paper looks like. And literally, this is what I'm drawing. It's like a little upside down looking H. And we actually call it mu. So anyway, so that's a mu. But anyway, sorry, I was suddenly thinking about wanting Chick-fil-A, but that has nothing to do with this video. All right, so we know what mu is now. All right, now here's what we don't know. What does it mean? Well, we'll get there in a second. So what does the little n stand for? Easy enough. That's a normal force. And at this point, you should also be going, well, what's a normal force? I don't know. We'll get to it in a second. But since it is a force, we know that the unit is Newtons. Very good, Sierra. Hey, good deal. All right, we're on fire. So the only thing at this point you should be asking, what is that mu? What is that upside down looking H? Well, mu stands for I always misspell this, the coefficient of friction. Hey, I'm great with numbers. I ain't got to be great with words too. This is known as a coefficient of friction. What's cool about this, it's a number. It goes between 0 and 1 basically. And I'm going to write this. I'm going to change colors. Game changer. There is no unit. That's right. There is no unit for a mu. So what in the world does mu tell you? Mu tells you this. Mu tells you how rough or smooth something is. The closer you get to 0, the smoother it is, the slicker it is. The closer you get to 1, the rougher it is, the stickier it is. That's all mu tells you. Go spray some butter spray in the floor. See what happens. It's borderline hilarious. When you spray butter spray on the floor, that surface smooths to like glass, and you will then watch people fall everywhere. Sorry, sometimes we decide to do practical jokes at the mall. Did I just admit that on video? Never mind. Ignore that. Do not bring butter spray to the mall. Well, I don't know. No, don't. I will not be someone who advocates shenanigans. Wait, I invented shenanigans. Anyway, let's keep moving on. We need to know what one more thing is in this video. What is N? What is this normal force that we're speaking of? Well, you see, right now, Sierra, she's standing beside me as I make this video, copying now what I say. So here's Sierra. There you, oh, wait, it's a girl, so we'll throw some hair on. Oh, I should have been an artist. Look, she got a nice grin. There's 2 cross-eyed eyes, just like her. So anyway, so there's Sierra standing on the floor. Well, here's the thing. Sierra is pushing down on the floor right now. She's pressing the floor. Now, that's what we call weight. So if Sierra is standing there, that means the floor is holding her up. So the floor is pushing Sierra back up beside me. So that force of the floor, that's what we call the normal force. Which means, wait a second, shouldn't these two be exactly equal to each other? Well, yeah, you're right. Normal force and weight are the same thing. Wait a second. we got an equation for weight. Weight is equal to mg. I'm going to agree with you. You're right. And which means normal force is also then equal to mg. Oh, my assistant got it. So that's how we find normal force. Now I'm going to give you a little hint. When you're working these problems, if you see a mass in a problem, it's like guaranteed money. You're going to use this equation in friction problems. Da, da, da. Now, if you're somebody who's like taking physics and you're looking at this, you mean N is always equal to mg? No, but it's not in physics, because this is a 10th grade video, and in 10th grade, everything's on flat ground, which means N is equal to mg for the purpose of 10th grade. In 11th grade, not so much true anymore. Spence looks at me and shakes his head. That's right, because he's a senior in his, good grief, second year of physics and calculus and all that good stuff at this point. He looks mighty dashing in his outfit today, I might add. So anyway, let's go ahead and take what we just learned, these two new equations, and let's work a few problems. So take a look at this first question I'm going to work. What is the force of friction present? Let's see if we can do this. Between a 250 kilogram object, that's a mass. Wait a second, Mr. Cole. You just said a second ago, if we get a mass, what should instantly go off in our head? N equals mg. It's like guaranteed money I'm going to do this. So N equals m, which is 250, times 9.8. Boom, because that's what G is. I think we're on Earth. Are we on Earth? Yeah, we're still on Earth. So anyway, we're on Earth, and I've got to find my calculator. Where is it? Oh, no, I can't find it. There it is, barely on the corner of my screen. Give me my calculator back. Somebody's trying to hide it. So 250 times 9.8. Sierra's racing me, but I'm going to beat her. 2,000. Oh, now she's bragging. 2,450. What should be the unit? -1. Oh, Newton. So there's that. Hey, we ain't even really read the question yet. What is the force of friction, though, it asks? So this problem asks you for the force of friction. That's little f. So I'm going to write mu, N. And we just found N right here. N is 250. And then over here in the problem, it gives us 0.32, no unit. What is that 0.32? Hey, that's my mu. So that tells me, by the way, 0.32 is a very, very slick surface. Hey, got a joke for you. You ready for this? Hey, two cats are on a roof. Here's a roof. There's a cat. Actually, I just drew two circles. Anyway, we'll pretend two cats are on a roof. One cat slides off the roof. The other one stays on the roof. What's the difference? The one has a greater mu. Mu, mu, mu. Get it? Get it? Get it? Yeah, the classics never die. All right, so now we've established that that's a terrible joke. Let's work this problem. F equals mu, which we just said is 0.32, times N, which is 2,450. Now let's see if we can't find that magic calculator again. Come back to me, Casio FX115 ES. So 0.032 times 2450 is 392 over 5, which is 78.4 newtons. Give yourself a round of applause. You have just found frictional force. All right, let's do another one. I'll tell you what, y'all are just shredding this stuff today. So let's see if we can't do this one. So this one says if a frictional force of 150 newtons. What? A frictional force? Wait a minute. So what is that 150? That's a little f. So that's telling me my frictional force. Hey, Sierra, look at that. You see that? She just bobs her head. Probably for the best. You can't hear her on here anyway. Plus, she's a low talker. It's a mass. Sierra, what did I say a second ago? What do you do every time you see a mass in one of these friction problems? She says she doesn't know. This is depressing. I said, this is like I put stars all around it. And I said, hey, if you're doing a friction problem and you see a mass, it's a heads up. An equation. What do I want you to do? Oh my goodness. She's totally wrecking this video for us all. You believe this? America's education in jeopardy. What do you do if I give you a mass? I said that is a red light that you're going to do N equals mg. So look at what I'm going to go ahead and do. N equals m, which is 100, times G, which is 9.8. Don't get out a calculator. That's 980 newtons. So there. So now I found what n is equal to. But the problem, let's see. Look at what it asks. What coefficient of friction? What's this problem wanting you to find? The coefficient of friction, which is the mu. So, hey, I got an equation with mu in it. F equals mu n. Well, this is cool. It gave me F, so I know that F is 150 equals mu, and I know that N, I know what N is. N is 980. Check this out. So how do we algebrate this? Well, we want to find mu, so that means we divide both sides by 980. So let's, oh, I'm in a race. Somebody's got the calculator out. You're not going to beat me. 150 divided by 980. Ah, she beat me. She has 0.15, and she's right. So 0.15 sig figs, that's probably all there is. So that is my mu. By the way, when you're doing a problem and getting a mu, I gave you some heads up at the beginning. Your mu should always be between what? 0 and 1. So if you work this problem and didn't get an answer of 0 to 1, either you messed up or I messed up making the problem. And hey, let's face it, I'm Turdferg. I'm not going to mess up a video. Actually, that's kind of a lie. Sometimes I do. Anyway, all right, last question. Hey, look at this. I'm not even reading the problem. Do you see this, Sierra? There's a mass. What did I tell you to do instantly in these problems when you see a mass? She nailed it. N equals mg. So look at this. So N equals, and if Sierra's great, she'll beat me to it with the calculator. 12 times 9.8. She's not beating me. I can get her this time. Where's my calculator? 12 times 9. Dang it. She's got me. She says it's 117.6. Well, you know, speed of a Casio. All right. Here's the great thing. We've got points at this point in the problem. Wow, that's a lot of P's. Peter Piper picked peppers. So what is this? That's a mu. But now check this out. Look at that 65. That 65 doesn't say friction. That 65 just says a force, which means that's a big F. What is this problem doing? It gave us a big F. And look at this. Look at what it asked you to find. You believe this. Acceleration. Hey, the other day y'all did problems that were two things were pulling on each other. What did we do when we had that tug of war situation going? Ooh, I heard Sierra say sigma equals F. Oh, very good. Which means what are we going to do with these forces? We're going to do what? Subtract them. Very good. Equals MA. And I've already gave you what F is. F is 65 minus something equals M, which is 12. Now, there's just one catch. What do I not know yet in this problem? I do not know what the F is at this point. So, but that's okay. I'm going to write F equals mu N. I already know N. I know mu is 350. N is, what is N? We just figured out 117.6. Now, quick with the calculator. Help me. Find this F. Someone save us. What is 0.350 times 117.6?
41.16.
41.16. So now, if I want to try and figure out this problem, I'm going to take that. This is my F. And I'm going to substitute it right here. 41.16. Now subtract the difference. 65 minus 41.16.
23.84.
And that's equal to 12A. So now divide both sides by 12.
1.99.
So 1.99 square, and kapowie, I have done that problem. So that was the only trick to it. Just subtract the two forces. All right. Thank you for watching a lovely edition of Turdferg Vision. Good.